Hello and welcome to this in-depth tutorial and look at the Crucible and how I automated a very nice setup for it to smelt alloys. This don't mean it is the best setup in the game, because the best setup is the one that fits your needs. I will go over many steps and information and show you how I build mine, so you can get some ideas what you can do with your own. So here we go. The first thing you're going to look at is the burning box itself and the crucible. They are the heart of it after all. Looking here into the two tips, we have a burning box of steel and one of ingot. You can see that they have a different energy out, that is the amount of heat they're gonna output. But that's nearly not that important as you might think. The efficiency is actually one that is very important. The amount of heat out is only important for very dense and heavy smelting. Not to be the case in here. The difference is how long the fuel you have supplied will last and how much heat is gonna be produced from it. Here we have a burning box of ingot and one of the steel side by side. I will put one pellet of charcoal into each one, and then I'm gonna heat it up. You see that the steel one rises very faster compared to the ingot because it has double the amount of out, but it's already burned its fuel while this one is still going on. So even though this took more time to burn the fuel, because it has a higher efficiency than the steel one, we actually got more heat out of the fuel it got. This is important not only in the beginning but also later on if you want to set up a automatic shutdown of the system, because this much in the case of the solid furnaces burning box, that they are gonna burn the last piece of fuel. So if the crucible is empty and they're gonna burn an entire piece of it, you need for it to actually finish burn it before it melts down your crucible. So in this case here, if I was to use an ingot one, I'll have to set up at least almost 500 Kelvin before the meltdown of the crucible. In this case, the ceramic one is 2500 Kelvin. So I had set up a limit to stop it at 2050 at maximum. I'll be running a risk of melting down my crucible if it was empty and still burning. Here on the side we have a dense burning box of ingot. That is the They have 4 times the energy output of the normal ingot, but even if it outputs 4 times, it also uses 4 times the faster. So even though it is 4 times stronger, it will produce the same amount of heat that one produces. So yeah, one of the important things is not just the amount of heat that's going out, but also the efficiency, mostly in case of shut off and everything else. Now let's talk about crucible itself. The most common one to be used for a good amount of time is the ceramic one, because it is very easy to make. Just clay, a rolling pin and a knife. They also have a good amount of heat capacity. However, if you can look below it, you can see that its weight is very low. It's very low. This means that they're gonna heat up very fast. While one heavy one, like this one here, made of steel, you're not gonna heat up so fast as it. You see, it's only increasing a bit compared to what this one heat up. But there is also some advantages, because it don't heat as much as the other one. It will be more easier to set up a limit to it to avoid it being burned out. And also because it is heavier, it will take more to heat up, but also more to actually cool down. Let's put another piece of charcoal on both the normal one and the steel one. Let me remove it just to replace it so it is actually empty. You see, when I added a piece of steel of iron here for this one here, the temperature drops a lot, but while here it barely moved. So they also will keep hot more time than the normal one, the ceramic. The ceramic is very good for you to do things manually, because you need to shut off it early and everything else. So while you're doing stuff on your own, it's better to use the ceramic. In my case here, since I'll be doing automatic, I'm gonna use the steel one, because it will be more willing with the limit of the smelting, and also the gonna be keep it hot for a longer time. And in this case, I also be using the invar dense burning box, but you can use any burning box, even the invar one. This is where my burning box and crucible will be, because the burning box of solid will produce ashes. You need to put something below it to actually get the ashes. So let's put a dust funnel here, and the default configuration is to make blocks of dust, and below it let's place a chest. So if you want to hold the ashes to make concrete and other stuff, you'll be able to. If not, just remove the chest and let it despawn. And as I said before, costs a lot of time. I need to actually shut it off at some point. So let's pick up sticky piston and a piece of glass. Let's put the sticky piston right here, facing up, the glass on top. Now let's get some redstone wire here, connect to the side, set it up to connect to the top of it, pick a red brick, place here, connect the other wire, another wire, and a thermometer. That'll be, in this case, set it here, and let's connect. Now let's pick our screwdriver and tell it to, when it is above let's say this much, it might have some signal and shut off. Just to see if it's working, that's chance to lower it. It is low because it's cold, so it works. A crucible has 4 facings, but because you're gonna have to do some automation and everything, you need to have some facings open, and you need to choose what each face we're gonna do. The way I set up this, I'm gonna use the front face that is closest, where I'm gonna shut it off when the glass block the entries of air into the burning box to the front. I will have the automation to send the materials to the crucible into this place here, so I'm gonna place the auto thermometer here to request and say it to make pour down the materials inside the crucible. So in this case, I'm gonna say that when it's up, when it is this hot here, emit redstone signal. Then I'll grab here some crossings and some mold and place here. I connect the redstone right here. Was the wire cutter to connect to the crossing. The crossing will transmit the redstone signal to the molds. Then I will just go here and click kind of in this rectangle here to enable the out input. And then click on the middle of it with the monkey wrench to set to when there is redstone to actually try to get the material inside the crucible. Now let's pick a chest, place it right here, and then a hopper extracting for each mold. Good. This part is set up to go. This will be the part where you're gonna request material from the network. I have here a vanilla redstone pulse lock that make it just send one single pulse into the system. But I have this repeater here with 4 ticks to avoid the redstone signal burning out sometimes. So if you click this, if I click it, let us quickly move the button up there because it is affecting the piston here. You see that it pulses once and stop. This is gonna be what we're gonna send a signal to request the items for the system. So here we're gonna make the first setup. Let's put some brass pipes down there. And the first one I'm gonna make is a setup to auto send the material to make it bronze. So one hopper here, another here, and one on top of each other. And then a chest to hold the materials. Now comes one thing different from most setups. The normal recipe to make bronze uses copper. And it is 3 copper, 1 tin equal 4 bronze. But my setups here are gonna make it a single ingot each time. So yes, all of this is gonna make it a single ingot each time. So I need to actually break the recipe into 4 pieces. So instead of being a full dust, we're going to break it into small piles of copper. That is 1/4. Same thing with tin. 1/4 of tin. Now I need to choose which gonna be each. I want this to be copper and this will be tin, or this copper and this tin. Makes little to no difference. So let's make the first one to be copper. So we did 3 copper and with the monkey wrench to say it to be exactly 3 copper. No more, no less. Now let's connect here just to connect and place a chest here. If I place it on, nothing happens. If I place it 2, nothing happens. But as soon as I put 3, they get outputted. So this is going to make sure that it's only going to output 3 of it and only 3. If I put more than it's gonna, and exactly size means it's not going to try to output multiples like 6, 9, 12. It's 3, 3, 3, 3. A consistent flow. Our same thing here for the tin. For the tin is actually 1, so just send 1. If I put 1 tin here, it will arrive here. But I don't want them to keep outputting whenever they want or receive an item. So let's pick some redstone alloy here, place down here, and get some redstone torches, and put it to the wire facing the hopper. This will keep them from outputting anything. But the problem is when they are headstoned, they do not output or drag items. If I try to place a chest on top of the hopper, it will not get any item from the chest until it is unpowered up. And because the time they're gonna unpower is just one tick to send the item, it's not enough to actually get the item necessary to continue making the alloy. That's for the reason I placed this hopper here, because the hopper will insert it wanting it or not, and this is gonna be where the rest is gonna be resolved. So I can just break everything else into a small copper here and place it as desired. But there is another way to do the dust stuff. So instead of using a hopper, I can use a dust funnel here and place here, and use a monkey wrench to change the size of it. This is dust. This is small dust. So if I want, I can just place a chest on top of here, and if I place in the thin dust here, it's going to be broken down into small ones without me needing it. Instead of a chest, I could also use something different. If I want to make it fancy or easier for automation later on, I can just use a wood barrel here. And in this case, I will just place it the smallest one, and they are going to fall down when necessary. But we actually can combine both of it. We can have an item barrel on top of the dust funnel, but different from this here that I have to set up the material correctly to the thing is going to become. I can actually insert the whole dust here. And the dust is going to be broken into smalls and arriving down here. So this is actually more efficient than doing this. So we have those two choices you can make it to how we're gonna store material to the alloys. And because this is far from the Crucible itself, they are safe, because the item barrel is flammable. And the burning box and crucibles can put blocks around it on fire, so they are a fire hazards. 4 blocks. So they are here. 1, 2, 3, 4. So you need to pay attention to it. You could also move it then for the back, and then we're gonna be completely safe. Now we need to actually make it possible to send the items here. I have already dragged down here a little line of redstone alloy to a little system here it looks complicated but has a reason here. So the first thing we're gonna do is actually just connect this wire here, and we can actually try to see where this is going, so we can connect it properly. It is right here. I will just give it a different color so I can actually easily see it. Then I drag a wire here, connect with this wire here, and connect both. They are now linked. Let's just make sure it is connected to the top of it. Yes, the block will transfer the redstone signal. So when I give signal, you saw it briefly tick the stone torches, and now we have the copper and the tin to make a single bronze alloy ingot. Not requesting. Another 3, 2, 1. Perfect. It's working as it should. But then we have a little problem that I need to actually fix up, because you need both items to make the alloy. How are we gonna prevent this to get one empty and send the other one to the crucible? That answer is quite very simple, just using item meters. In this case, I'm gonna place one on this side here and the other one on this side here. And then I set up them to, when lower than 3, it's gonna emit a redstone signal. And same thing here. But since this is 14, when it's lower than 1, it's going to emit a redstone signal. Then we'll just place a repeater here and connect a cable, and then connect to here, like so. But one thing is different. Normally, instead of doing this that I have done here, that is using redstone torches here, the signal would be on all the time and the pulse you're gonna turn it off. So let's just do that. Instead of this being just connected, let's put redstone right here. And then we go here and actually removing those redstone torches here. And yes, they are outputting like crazy. You have to connect, of course. Now they should have stopped. That's a problem. We cannot actually see how much items we have inside. This one still have items. And those in this as well. But let's say we take everything out here. When there is that is not the materials, it's going to have some signal, connect to this one and lock this in place. Just to show, let me give it 3, so we have a lock for one alloy. Then it requested one item. It arrived here, but now it is locked. So even though I try to request another item, nothing will happen. So it has self-locked itself when it's receiving another item to another smelt. It's going to turn it off and start again. Let's put it 4 ticks here to give it a little breather before receiving another redstone signal. With this, we have automated the bronze alloy making. When it has an another item to make it one bronze ingot, it's gonna send it when requested. When there is not a knocking, it's gonna lock itself until it receives more. Good. Just a quick thing before I move out to the next automation is that instead of using the dust funnel and item barrel for the tin, if you use a lead hopper and a lead chest, you can actually have tin or zinc here, because brass is made from smelting the same amount of copper that bronze do, but with zinc you can make this become a bronze brass auto smelter, but then you're gonna have to auto feed the zinc and tin inside if you want to use it as that. Okay, now let's move to the next one, that is to make it actually iron. One of the first ones and probably most easy ways to make iron is using basaltic black sand that is all over the world. As you can see here into this river here and into my let's play, I have a lot of black sand around my place here. It's very easy to find it into the world. And as you can see here into the recipe, to make it into iron, we need 14 basaltic sand, black sand, and 6 cobalt dust or charcoal dust. Each cobalt dust equals half a carbon dust. Nice. However, we have a little problem. A crucible can only hold about 15 units of material, and when we say units is not simple, small ones, like tossing a charcoal pellet does not count as one unit, because it is 1/9 of it. So if I throw 9 charcoal pellets, it's going to be 1 unit. So this recipe already overflows the crucible. Most people what to do is cut it by half by making 7 black sand and 3 coal or charcoal. Don't need to be dust, need to be only charcoal or coal. But that will make 3 of it instead of 6. But you actually need to make 1 of it. For setup is do the same thing I did before. 2 hoppers, then another 2 hoppers. And as before, I need something to stop it from outputting when I don't want. But because the orientation is different, the flow goes from here to there. Instead of being here, they're going to be right here. And I connect. And they are locked. Even if I plus something here, they're not gonna output. Now I need to choose what's gonna be what. I'll choose that this one here is gonna be for the coal. Since you need only 1 coal, stack size of 1. So here we go. But now what we're gonna do about the granite sand? You see that it was 14 to make it a simple one. I cannot divide 14 by 6 perfectly. What we're gonna do is to process the black sand a bit until you get the granite mineral sand. You can get it from various ways. The most common is just to into a sifter. Sift got the good nugget. Sure, they're gonna get you 100% the black sand, and the centrifuge gonna have again 90%, but it also has 10% again this vanadium pentoxide that is useful later on. So it's up to you how you're gonna get it. But on this case here, I'm gonna get it. Again, I cannot divide 14 and 3 and 6. See? Do not go. However, taking the 7 that before, that make it 3, and breaking them into tiny piles, will give me 6-3, and 6-3 I can divide perfectly into 3. So if I put it 21 tiny dusts, I have enough to make it a single iron nugget. So yeah, 21. And now we could test to see if it's gonna work. However, I have a little problem here, because we have the bronze in the way. But if the bronze was completely out of materials, it would not going to affect it. Is there a way for us to do something about it? Yes, there is. We have the wire for when it keep itself shut. If I connect it to this blue that I make here to mark the place here, have this wire coming here into a redstone torch that is powering this repeater and stopping this repeater here. This is where the line will gonna come. And this is the same line right here that's going to, with the pulse, disable the torches for it to send the items. The pulse will gonna come this way here, and because there is bronze to be made, it's gonna to hold the signal here, so avoid need to go further on. If I try to request one item here, I get the copper and tin, but this one here, nothing, even though it is here. But when this run out of item, it will send a redstone signal from the hold itself on here, burning off the second redstone torch here, disabling this repeater and allowing this to send a signal forward. And when I click it, you have our charcoal and our granite sand. So this way, when I have run out of bronze or brass to make it, it will go forward and start to making iron. It's a pretty interesting system, isn't it? We can still make everything and one ends. It will allow us the other one to continue. And as soon as I place back one item to make the previous one, it will block the next step. So I request this one here, gonna have more tin and copper. It run out, it closes itself, and now we're going to have charcoal and granite sand to make iron. Very good, very, very good, in my opinion. And here is the same as before. If you want to use a hopper or a dust funnel with the dust of choice, is up to you. By the way, we do have coal coke in the game, and a coal coke is worth a whole carbon dust. So if you got coke, you need to actually break it into, first make it a brick and then break it into chunks, and only send it 2 chunks to make it the same amount of carbon that a single charcoal does. So if you want charcoal or coke, don't forget to keep this on mind. But make charcoal is easier at the start and to keep up and down making coal or coke. So it's up to you. Now we need to set up the shut-off as we did for before. But different from before, instead of going into the front or back, we actually can use front or back, to be quite honest. Don't need to be like this. Now, if you have less than 1 color, send signal, and if you have less than 21 of this, send signal. 1 wire, connect to the blue down there, right here. That is holding this repeatable going on for the next alloy that you're gonna make. When there's run out of coal, it will allow this to continue, and I have to put the repeater to stop itself. Cannot forget that. I almost forgot. There. It's now frozen in place. Even if I request something, nothing should arrive. Good. But as soon as I put 1 core here, it's off. If I request, there you go, charcoal, sand, and it's off again. Very good. You are working as intended. And now we move on to the next one, that will be a little bit complicated. So I hope you pay attention, because this might be a little surprise for you. We have now probably the most common way to make iron after the black sand is using yellow limonite, brown limonite, or hematite. Actually, those are hematite, to be honest. As you see that when they are placed into the crucible and heat up to this temperature, they become half a hematite. And hematite can be made into iron with 5 hematite, 1 carbon, 1 calcite, make it 2 iron. So for our single alloy, single ingot making, we need 2.5 hematite, half a carbon, that is as charcoal, and half a calcite. So here we need 3 materials. So we need to have a bigger pipe than before. At least 3, you would think, but no, let's make 4 of it. You're gonna understand it very soon. Now let's pick our hoppers here. Let's place the first one into the second pipe and the other one into the third pipe, like so. and as always, this and this, and then onto the other side, one into the first pipe and another one into the last one. And then need to decide which gonna be which. This I have already decided. This one gonna be calcite and this one gonna be the coal, or charcoal in this case. So let's bring our cable here and actually prevent them from working. But this time, because we're gonna use both sides, we need to actually pass the wire below it. So let's just dig from here. And then connect. Now they should not output because it is connected down there. If I place a charcoal here, nothing gets out. Since I need only half a cable, one charcoal is more than enough. This one here gonna be calcite, but calcite only require half of it, so I need to actually break them into chunks. If you're using the dust, you need to make it into small dust. So yeah, you can actually make them into dust itself. You can use a mortar or a shredder for it. So pick your poison. Exactly 2 of it. And do it, of course. Let's open this pipe here and connect a chest so I can test it later on. Now comes the big choice. One gonna be for the limonite, another be for the hematite. So which gonna be which? I decided this one here will be the yellow limonite one. And because I said before that each one worth half a hematite and we require 2.5 hematite, so 1 hematite, 2 hematites and a half, so it is 5, exactly 5. But now I have something different. Instead of using another lead hopper that is very easy to acquire, let's use a bronze hopper because it has more slots, and do the same thing here, divisibles of 5. In this case I can leave the exactly or not to your liking. Why is that? Because I can use yellow limonite and brown limonite with each other, so I don't need to actually discriminate between one and another. In theory, you could actually use like 3 yellow and 2 brown to make 5, but trying to make this into the system would be so complicated. So for now, let's just lump them together. I can place 1 yellow and one brown, nothing happens. But when there is 5, it's going down there. If I have more here, not gonna happen with the brown because there is yellow here. But as soon as all the yellow goes away, all the brown comes in. And same thing, when the brown goes out, the yellow goes in. Cut. Shall we test it to see if we're gonna receive 2 chunks of calcite, 1 charcoal, and 5 lemonites? Let's see. And here we have it. It's working as intended. But this one has run out of charcoal already. No, it's not here. It is here. I only start to forget it. More 5, more 2, more 1. More 5, more 2, more 1. And now 5 yellow, more 2 calcite, more 1 charcoal. It works perfectly. Now, this one here gonna be for the hematite. So let's put a simple one here. But since we require 2.5 hematites, I think you know what we need to do. Break into small piles. And instead of 5, because it only was half for hematite and this one only 1/4, we need 10. Exactly 10 hematites. So let's put it then all down here. But now we have a problem. If I leave it like this and request an item when there is still limonite there, this is gonna happen. For limonite, calcite, charcoal, and hematite. This is gonna throw off the recipe. So I have trying to think a way to make I can use both of them into a simple one single system here without one getting in the way of the other. And what I found is this. So let's place here into this face here an item omitter that says that when there is more than 4 items, it's going to emit a redstone signal into its facing. Let's place a cover here and place redstone repeater on top of it and give it a 4-tick delay. So when this heavy, you see 4 items do nothing. 5 items, we're gonna activate this redstone repeater and lock this down here. And because of the delay, even when it is removed, it will take still a time for it to allow this to work. With this in mind, let's put this limonite here and let's try again. Request limonite, calcite, charcoal, nothing else. But if I try right now, calcite, charcoal, and hematite. Now I can use all the bar limonite before, and when it's over, it's going to start to using the hematite I have. So this way we not only automated the limonites, but also the hematite into a single item recipe. All that's left is to set up the shut-off. But because this place here is a little cramped and has this strange thing, you need to do something more ugly, like make it flying cables on top of it. 1 for charcoal, 2 for calcite. This time we don't need the one for the brow for the limonite because there is the hematite later on. And then last one. Has less than 10. Send our regards. And this is to prevent it from ticking again. And now it's on and should not tick anything. Empty. Something is not right here. You did not connect the wire, so it don't work. Nothing. Good. Very good. So here we have it. We have the bronze/brass here. We have the iron from granite sand or black sand. And finally our iron smelting that uses brown and yellow limonite. And then hematite to make it iron. Perfection. Now for the last test. Almost. Now it's actually time to connect it to the crucible. Last but not least, you need to actually deliver the items to the crucible. So let's start putting pipes around. Of course, the longer the pipe, more time it will take it to actually arrive where it's going to be needed. And we need to set up it correctly, of course. The longer the pipe, the more time it will take to take it to the crucible. But since I'm going to use the denser one, that time to travel there won't matter too much. If it was a ceramic crucible, then it would matter a lot. Now I have a little interesting problem here. That we have these pipes with material coming from two directions, and we need them to go into the crucible that is in this direction. But taking how the game is, one item that comes here might try to go all the way here before trying to actually go in there. Normally I would use shutters to do it. Shutters, not sheet. But they require aluminum. Oh, that's not close enough. We also have relays. This inventory extender that require electron pipes and steel. It's not that expensive, but not as good to use. But fear not that Greg sneaked something to help us. If I take my monkey wrench into the side here and click it, we can change it. It changes from accepting from the side enable, but emitting disable. No. Accepting from the side disable and emitting enable. Yes. So it can output but not receive. So the same thing here. I want it to output but not receive. And this one here, you have the accepting enable but emitting disable. So now when you connect these pipes here, they all should arrive here, and the only place to go is there and no back way. Good. How about a little test? Let's remove the crucible because I don't want to deal with the mess of scraps, and place a chest here instead. Now let's go here into bronze here and give it a piece of tin so it can actually work. As you can see, it's slightly off already. Now here we are missing a piece of charcoal, so let's give it charcoal. And as you can see, it's ready to work. And this one here have all the materials it needed to work. Calcite, limonite, hematite, and charcoal. Good, good. So if I request an item here, the first one to arrive will be bronze. Here we go. 1 tin, 3 copies, nothing else. And lights up. Second will be the charcoal and the granite sand. And nothing else. The lights up, so it's locked. And now for the last one, we're going to receive calcite, limonite, and charcoal. Let's remove all the yellow ones. Let's put 5 yellow here, because we got the brown one. Send the item, calcite, limonite, and the charcoal arrived. And now calcite, hematite, and charcoal. Perfect. Everything is perfect. And let's say that it is run out of charcoal and try to request anything. Nothing arrives. Alright. It is done. Oof. Now, if you go down here, we can see that the system that I made here is working as intended. And we can keep expanding it to make other alloys. Because here, we have this one to make iron here, those two to make iron actually. You might think, I can sneak a hopper here to place nickel and make invar. Yes, you can, but that's not advised because this is going to mess up things and it's very easy to have everything go away. So if you want to make a setup for make invar that you're gonna need a lot, I can actually make the setup in this place here and just continue the system of locking itself and allowing the other one to work all the way around. Later on, I will do one for stainless steel. I'm going to use the same setup here. And stainless steel is 4 ingredients: rogue iron, invar, chromium, and manganese. So it's going to be just 4 hoppers. Somewhat like here, into the shape here, but no need to trick systems to block one hopper or another. It will be very easy. And it's also very easy to make just a single ingot, because you got 9 of it. You just need to get 1 nugget for each one. So 4 nuggets of rogue iron, 3 nuggets of invar, 1 nugget of chromium, and 1 nugget of manganese, and you have yourself 1 stainless steel. Now it's time for the real test. Now it's time for the real test. The crucible is in place. All that left is to actually give you the dense building box feel. Normally you have to insert it by the front, but if you attach a hopper to any of side of it, you can actually insert items with it. But since this face here is this face and this face here, this one is not actually in use, so we can actually use it. Mission failed. I can actually attach one hopper here, a pipe here, and place a chest here, a hopper here, and then grab a chest, and there's gonna be the furnace fuel. Normally for furnaces I use the charcoal pellets because they will burn not much and quickly vanish, but because this is a heavy crucible, I can actually use something more stronger. Not the entire charcoal, which that is whiskey, but I can break it into chunks. So let's feed it some charcoal chunks. And light up. And it's now working. This face for now is free, so let's place it at the thermometer so we can actually watch it. And this is a dense burning box of ingot. 64 heat units. But as you can see, it's not heating that fast because it is a heavy crucible, as I told you. But there is advantage for that. And as you saw, the crucible is still empty. There is nothing inside. Should I request it? No. Because when they get to this temperature, it's going to request it on its own. That is the purpose of it. The button here was just to test the system if it was working as intended. So I'm gonna just have to wait to get to that temperature. And we are close to it. So we're gonna request the first item. And it has arrived. I give it 2 bronze to smelt. And as you see, the temperature do not drop it too much. We're gonna already output the first one now. Wait, what? Why you no work? Oh, I see. I knew something was strange when the below part was empty. The crossings can only receive a signal from below or top. So I have to actually do this. So let's do a manual dumping for now. Let's try this again. 2 bronzes, 2 black sands, and then the hematites. There is still some iron from before, so ignore that. The bronze has arrived. Very soon we're gonna get to the temperature required to make the pouring. There it goes. And the second batch of bronze has arrived. And very soon it's gonna be dumped one. There it goes. This one is still here. Now it's gone. And now the first batch of iron from granite sand has arrived. And very soon gonna be made into rogue iron already. And soon gonna be dumped. Now the second granite iron is here. As you can see by the light up. And very soon gonna be poured down already. And there it goes. And now this one is the iron with calcite. You saw the white stuff, that stuff was calcite. So it's been making with the brown limonite. And now gonna be for yellow limonite. And it's making. Very soon these are gonna disappear. As you see, the temperature don't drop that much with this crucible. If it was the other one, would mostly start from 0. And now gonna be the one with the hematite. You can watch it kind of here. We have 54 here. Now we have 44. And it's going. It's going. I already made 4 bronze and 7 rock iron. 6, now 7, now the 8, the 9 is already here, and it's going to keep working until it's over. Let's remove the charcoal from here, so we're gonna stop. It requested, but nothing arrived. When it got that temperature, it's going to block the entrance and turn it off. Very good, very good. All that's left is me to have a way to actually block the request of new items. I'll just place here a lever so I can actually turn it off when I want it, and make this little contraption here to prevent the request of new items when we're working or anything else. Let's back for now. Alright, I teach you almost all of it. There is just one teeny big thing left, that is to actually make steel. To make steel is a special way. We have to have rogue iron into the crucible with this amount of air and at this temperature to start making iron, like this steel itself. And what gives air? As the two people on the crucible say, kinetic units input will turn into air for steel making. And what makes kinetic units? The steam engine is one of them. So I have to actually place the kinetic engine against the crucible. That's why this face was vacant. Now I have to remove the thermometer and place a steam engine against it and put it to work to inject kinetic units inside it and produce air for the steel making with it. And the steam engine, as the name say, require steam. Minimum 24, maximum 96 steam. I am using a steel boiler. They make 64. It's a good amount. And taking account how much that is, that 24 is equal to 6. So divide by 4. So this will be about 16 kinetic units each tick. That is 20 ticks every second. So that will be 320, and we need 1000. So it's almost 4 seconds for it to generate that amount of air. Let's use the same, and this we're going to require a burning box to make to heat up the boiler so it can actually run. And since it is a burning box of solid, it also needs to be deal with the ashes, and the boiler itself requires water. In this case here, there is no water. Greg recently or sneakily added bronze drums to the game. Before I only had the wood one, and the next one would be stainless steel, but now we have a bronze one. And I cannot use a bronze something made of wood close to burning boxes. I think even this is now in danger. So this one has distilled water that we're gonna use to make the supply this boiler with water. But if you, just because I'm gonna use it for a quick demonstration, when you want to use it for a very long time, you need to have a constant supply of water. And let's see, it's still empty. We'll fill. Now start to getting water from it. And the steam that is being used for by the engine will produce back some of the distilled water it uses, so it can actually recycle this water. So this will be not run out of water for some time. So in theory, all I have to do is to light up the boiler and the crucible in a high enough temperature to smelt iron. So I can actually use the limonite and hematite setup I have here. I think it's only missing charcoal. Now it's gonna work. Let's grab some charcoal for the boiler itself. And this time let's use a full charcoal because boilers eat fuel like crazy. Now I just have to start that. One goes here. And the one goes here. Now because there is no facing left to me to click it, I have to do it with thermometer. But this crucible gonna hit it faster than the boiler does. See? Did not even started. Because it's gonna take time for the thing to turn, I need to actually increase the limit here. I'm gonna wait for it to happen to actually explain it. It's already requested the first item here to be made, and the boiler is not even close to starting producing it. So I'm gonna stop for a bit. Try to stop the burning box, not the boiler. Good. The boiler got to the temperature and should start being producing steam. As you can see, it's being produced and being used by the engine. And you can see the color change. It is running. Now comes the tricky part of it. You may think that because it is running, it is injecting air into the crucible. But I was enlightened by the community and the auto model and everything else that that's not true. Only when the crucible is at that temperature is that the engine is going to start turning the kinetic energy into air. So you have to keep it above this temperature for it to start to receiving air. So you need to actually increase the temperature for pouring out. And let's see if there's going to be a knock. Or it's going to be too fast. Now let's see. So I'm going to start to getting to that temperature. And now it's starting to inject the air. And it was time enough for it to actually inject enough air to become steel. Let's see this one. Yes, it was enough. So at this temperature, it is actually fast enough to create steel. it seems. Yes, it is. If I want to make it still faster, I need to put a stronger or inject more steam into this one, but this one is already running very close to its capacity. It's producing 16 for now. If we make a stronger engine, like let's say the strong one of invar that can go up to 64, it's gonna be, and give it enough steam to work at the max capacity, it's gonna be even faster. So now it is doing steel for us. Oh. I can see the temperature of the ball itself. Nice. Oh. Don't forget that the steam pipes are hot. And as I can see, pressure is not being built up because it is using all the steam. So with this, we complete all the steps for automation. Now the setup here can make bronze brass, can make iron, and if I have injecting vacuum unities, it can make even steel if I want. If I don't want steel, I just need to turn this burning box off. And never, I mean never ever, try to remove a boiler that is hot above the white side. It is going to explode in your face. Don't do that, okay? If you don't want to use a engine so strong or anything, just use a weaker burning box, so you can give it more time before it hits the temperature to shut off. In this case, because I am confident into my heavy crucible and strong invar boiler, I did go all the way. Just as a quick reminder that if you want to shut down the system at some point to avoid it producing more of that material that you don't want more, just look for the circuit that causes the shutdown and the allow of the other material. Place a plate into the wire and lever, and this way you're gonna block it from working. So now I can choose. I can have tin and copper here, and will not work while this is active. Just a reminder that you can actually put something like that to manually remove it from the chain line and not just not feed the material to it. Okay? We made a pretty decent amount of steel. 12 steel plates, and still having a good amount of distilled water here. Very good, very good. So this will be it for this in-depth, very long tutorial on making this kind of automation I made here. I am quite happy with how it turned out, but to be honest, I was not sure if this was not a course set, because this is like the 5th time I recorded. But I am kind of glad. It's now looking very much more neat and well placed than the first one. So again, this was On God. Thanks so much for watching this.